In this lesson, we're going to talk about solving equations with radicals. So that would be equations with square roots or To solve an equation with a square root, the very first thing you're going to do is isolate the square root. That means get the square root by itself. So in example 1a, to get the square root by itself, I have to subtract 4 from both sides. So now I've got square root of x minus 3 equals 3. That was step 1. Step 2 is square both sides. So if we want to get rid of a square root, we have to do the opposite, or square it. That's going to get rid of the square root on the left, so now I just have an x minus 3. And then on the right, 3 squared is 9. So that was step 2, I squared both sides. And then finally, step 3, we should have something we can solve. In this case, solve just means add the 3 to both sides. And we're left with x equal 12. Now with equations with square roots, we do have to check our answers. It's possible that you might get an extraneous or a false solution. And so you want to take your final answer and put it into the original equation. So square root of 12 minus 3 plus 4 equals 7. Square root of 9 plus 4 equals 7. Oh, this one does work. 3 plus 4 equals 7. So our answer is x equal 12. Let's take a look at another example. So step 1, isolate the radical. That has actually already been done for us. The square root is by itself. Step 2 is square both sides. When we square the radical on the left, that gets rid of the square root, and I'm left with 6x plus 7. On the right-hand side, x plus 2 squared, that's actually a FOIL problem. We can't distribute exponents when we have sums and differences. X plus 2 squared, let's see, there's a pattern. This should be x squared, and then you take the 2 and you double it. 2 plus 2 is 4, so 4x, and then 2 squared is also 4 plus 4. If that pattern doesn't make sense to you, you could also write it out and you could use FOIL, and you should get the same answer after you combine like terms. Okay, so right-hand side, we've got x squared plus 4x plus 4. Now this time we have a quadratic equation, something with an x squared. We've only talked about one method for solving quadratics, and that was factoring. So first thing I have to do is set one side to 0. And I'm going to do that by subtracting the 6x and the 7. I really want the x squared to be positive, so that's why I'm going to take everything on the left and move it over to the right. So now I've got 0 equals x squared minus 2x minus 3. And this one we can factor. I know that 3 times 1 is 3, and if I make it a negative 3 and a plus 1, that does add up to negative 2. So then I set my factors equal to 0. I end up getting x equal 3 and x equal negative 1. Now, unfortunately, I'm not done. I do have to check my answers, and I have to check both of them. It's possible that both of these solutions work. It's also possible that neither of them work. And finally, it's possible that one of them works. So I'm going to check x equal 3 by plugging that into my equation. So let's see, 6 times 3 is 18. 18 plus 7 is 25. Does the square root of 25 equal 5? Yes. So 3 works. And then I'll check the negative 1. So let's see, that gives me a negative 6 plus 7, or 1. Square root of 1 on the left. And then negative 1 plus 2 is 1. Yep, that one works as well. So we happen to have 2 solutions to the equation in example B. Let's do one more with a square root. Isolate the radical. So this time we subtract the 10. Square root of 2x plus 3 equals negative 1. Step 2, square both sides. Squaring the left gets rid of the radical, so I've got a 2x plus 3. Minus 1 times minus 1 is plus 1. And then I'm going to subtract 3 from both sides. So 2x is negative 2. Divide by 2. X is negative 1. And once again, I have to check. I'm going to check in the original equation. So 2 times negative 1 plus 3 inside the square root plus 10. Does that equal 9? Let's see. Minus 2 plus 3 is 1. So I've got square root of 1 plus 10. Does that equal 9? 1 plus 10. Oh, that does not equal 9. So this is an example where our solution actually didn't work. Since there's no other solutions, I'm just going to write down no solution. This is an equation that doesn't have a solution. Now we can use a similar process if we have a cube root or a fourth root. We want to make sure we isolate the radical. That's already done. To get rid of a cube root, you can cube both sides. Oop, I wrote that down wrong. To get rid of a cube root, you cube both sides. If it was a fourth root, you would take both sides to the fourth power, etc. So now I'm left with x minus 2, and then I have to figure out what's 4 times 4 times 4. It's 64. Add the 2, and x equals 66. It turns out with cube roots, or any odd root, you actually don't have to check your answer. Those false solutions pop up because whether you square a positive or a negative, you get the same thing. So it doesn't happen when you have odd roots. Although, if you want to be safe, it's just not a bad idea to always check your answer. It's never wrong to check your answer. But you only actually need to check your answer if you have an even root, like a square root. So finally, the last thing I want to talk about in this lesson is a special type of kind of equation that has square roots in it, and that would be the distance formula, which is just a variation of the Pythagorean formula. So we learned in the past the Pythagorean formula applies when we have right triangles, and that the sum of the squares of the sides of the triangle equals the square of the hypotenuse. A squared plus b squared equals c squared. So what I want to talk about in this lesson is what if we want to find the distance between 2 points? So let's say we have the point x1, y1 and x2, y2, and I want to find this distance d. There's a formula that we can use, but I want to show you where that formula comes from. So I could compute my change in x and my change in y, kind of like when we're finding slope. So I could find my rise and my run. And now I have something that's a right triangle. In this case, we could say that the run squared, that's my a squared, plus the rise squared equals that hypotenuse, or d squared. And if we wanted to solve this for d, we could say d equals the square root of my run squared plus my rise squared. The run is the change in x, so this would be the square root of x2 minus x1 squared, and the rise is my change in y, or y2 minus y1 squared. And so this result that I just ended up with, this is what's known as our distance formula. So if we want to find the distance between 2 points, we can use what's called the distance formula, or it turns out we can actually draw a right triangle and use the Pythagorean formula. The two formulas really come from the same place. So let me show you an example. Find the distance between the points -2, 5 and 4, 2. So I'm going to start by drawing a picture. -2, 5 is right here. And then x equals 4, y equals 2, that's right there. So those are the 2 points we're working with. We're trying to find the distance between them. And so I could just plug these numbers in, the x1, y1, and the x2, y2. I could just plug them into my distance formula. Or, if you're a more visual person, you could turn this into a right triangle problem and then compute the lengths of the sides in red. And so I can see that the base of this triangle, it goes from -2 to +4. That's 6 units long. the height of my triangle goes from 2 up to 5, that's 3 units. So using my Pythagorean formula, 3 squared plus 6 squared should equal d squared. So 9 plus 36 equals d squared, or d squared is 45. And then to solve, I would take the square root. Although 45 is 9 times 5, 9 is a perfect square, and so in simplified form, my final answer would be 3 root 5. You could also use the distance formula. You could just memorize that formula and plug those numbers in. So your change in x would be 4 minus negative 2, that's squared, plus y2 minus y1, so negative 2 minus 5 squared. This should give you the exact same answer. Personally, I like to draw the picture because I have a little bit less to memorize, and it just makes a little bit more sense to me with a picture. So that's it for this lesson. Please let me know if you have any questions.